there's a lot of slides, but I try to keep it not too boring. So until I started the AI team at MotherDuck last year here in Amsterdam, pretty much 1 year ago now. And you might be wondering, what is MotherDuck? Might have not heard about MotherDuck before, so I'm going to start with an introduction about MotherDuck. So who are we? We are a company that was founded in May 2022. Since June 2024, we are GA, and we have around 55 employees worldwide. And I think 9 of us are based in Amsterdam. We are VC funded, and we are lucky to have a DuckDB Labs partnership, and we work closely together with DuckDB Labs. And what are we doing? We are designing systems or data systems for the post-big data world. What does it mean? We want to build a data warehouse that actually leverages local compute as well as single node cloud compute, object storage, all these kind of things. So you don't have to pay the big data tax. So what is it motivated by? So local compute, everyone sitting here has probably a notebook that is using for work, and that mostly sits idle unless it's currently compiling some code. And with DuckDB, we can actually leverage that to process your analytical queries. So second thing is, as I said, single node compute. So because distributed compute is still painful, you see 2 workers concurrently processing a bottle of wine. That doesn't look too convenient. Yeah. Single node compute in the cloud is actually quite powerful. So there are up to 24 terabyte machines with up to 24 terabyte of main memory, almost 500 cores available in the cloud. So that's a lot of power for the DuckDB. And so MotherDuck is basically a DuckDB extension for scale up and for collaboration. And it is as simple to use as that. So instead of connecting to your local DuckDB database file or opening a CLI session against your local DuckDB database file, you can connect to MotherDuck instead. Of course, in this case, my MotherDuck token is an environment variable, but once that's set, you just connect to MotherDuck and you will have access to your local databases. You can still attach your local DuckDB database to the same session, but you also have access to shares, which are shared DuckDB databases in the cloud. They can be shared with all other users or only with users in your organization, and they can also be joined. MotherDuck also comes with a web UI that is WASM-based. So even when you run queries in the web UI to do data exploration or development, you can actually leverage your local compute with that. And at the same time, of course, when you run queries against remote data sets, it could also be data sets on S3 or Iceberg, you can leverage the cloud compute side of MotherDuck. And there's more. MotherDuck has a large ecosystem of partners and different connectors. There are, of course, also an intersection with the DuckDB ecosystem and connectors. And there's also WASM SDK actually from MotherDuck that can be used to build very low latency data apps. I think Hannes mentioned it earlier as one of the use cases to build low latency data apps. And that's something that MotherDuck enables, but also it takes care of managing the respective data in the context of your enterprise or of your users. So one thing we did on the AI side, just as a starter, for example, is this data app generator. So this was inspired by Claude Artifacts. I don't know if anyone here has knows that or has used that before. It's basically this AI chatbot that can build applications. And we did the same to build MotherDuck data applications. Send a prompt, I want a dashboard of Hacker News posts, and it will start spinning and show you a live data app, and you can iterate on it. And so now I think I added a chart when clicking on a certain column in the dashboard, and there it is. So it's really, I'm always really amazed that these things just like work. But of course, this is more like a demo and something to play around with, and not a super serious project yet. But you can go on GitHub and try it out if you want to. So in general, I want to cover a few topics, and I hope we get to all of them, but maybe I just speed up towards the end. Or Gabor, maybe remind me like a few minutes before. Perfect, thank you. First off, I want to talk about text-to-SQL, because that's always a topic that comes to mind in the context of AI and databases, and talk a bit about where I think we're currently standing, or this field is standing, and show a little bit of the things we have done, and then go through a couple of other, I think, interesting topics. So I want to start with a quiz. So are there any DuckDB users here, like day-to-day users? Okay. So would anyone be like know the query for the first question by heart? So I have a table and I want to get all columns that end with underscore amounts from that table in a single select statement. Okay. People might think I bought you because you are also a MotherDucker, but okay. Yes. Exactly. Yes. So, okay. Let's not go into the details of the exact syntax, but you could instead also just ask the DuckDB text-to-SQL model that we fine-tuned. So, second one, I think that's a nice one, reservoir sampling. I don't know if people do that often, and I would definitely have to go to the documentation what the exact syntax is, but we can also just ask the model to tell us what the syntax is. And summary statistics, give me summary statistics of the table. There are just a lot of functions in DuckDB that are, I think DuckDB has more than 600 scalar functions in total. And of course, different parameters and all these things. And I don't know how often, like, that's the reason why you get 1.3 million visitors a month. Yeah. So this model is on Hugging Face, so you can run it on the website. You can go to a website, play around with it. But what is also really cool, you can use Olama on your local machine. So that was one of the reasons why we wanted to train a smaller model. Of course, you can do things like that with ChatGPT as well. And nowadays, on the next slide, I will show some benchmarks. It's also pretty good at speaking DuckDB, but you can now just run this locally without exposing your schemas to some foreign company. So this is a benchmark I just mentioned. So we built a benchmark where we just keep track of how good are current models at writing DuckDB SQL. Currently 0.1. Preview from OpenAI is leading, Claude 3.5 Sonnet next, but surprisingly Qwen 2.5, a small language model, is following, and it's actually better than our model by now. I think this was 9 months ago, and we are working on training a new iteration of that is also knows about newer DuckDB versions. This one was 0.9, I think. So, and there's also a Hugging Face space now where we collect these benchmarks, and you can run your own benchmarks there if you want to. So let's take a step back from there, because there was some confusion around what this DuckDB text-to-SQL model is, or where text-to-SQL is going is also a constant question. So I just want to think about it in terms of different roles. So we have business users who might be doing analytics, or who might want to get insights from data. They mainly ask questions. They know nothing about SQL, mostly. Data analysts, data scientists, who are really the data experts. They really know the data they are working with. They are also good at writing SQL, mostly write analytical SQL queries, though. And then there's the type of software engineer that can be all over this. I was really surprised. 25% of DuckDB users are software engineers. So that's a really important audience for DuckDB. And yeah, but they and data engineers are not necessarily so much interested in analytical queries only. And when you look at this whole landscape of Text-to-SQL tools, and also the academic side of things, yeah, this whole thing is 99% focused on analytical queries. I'm sorry that it's so small, but it's basically just a list of all the machine learning model or machine learning papers about Text-to-SQL from the recent years. And what I want to get at is this basically just serving one of the users of DuckDB SQL, of DuckDB or of data warehouses, which are the analysts. So nowadays you would do Text-to-SQL plus retrieval, which means you look at the query history that the users use, that the users have had, and you would look at other data documentation and build a retrieval mechanism on top of that, and then generate queries from that. But they can be regarded as drafts. They are often not really the exact kind of query you want, but they might be a really good starting point. And I feel that a lot of companies are also leveraging that nowadays to become more productive on the analytics side, but it requires SQL knowledge. So this DuckDB and SQL model is more going into all the different functions, not only analytical questions, but also more the DBA type of like copy into statement, for example. And it's more like saving a round trip to the DuckDB docs. It's not suitable for generating super complex queries. But then there's this left side of business users. Yeah, so people who only care about the results, not so much about the SQL itself. And I would say there's currently not really a good solution for that. And I wouldn't dare to let the existing Text-to-SQL models into the hands of any non-technical user or any user who can't verify the code that is actually generated. So this is a bit, of the current problem with the Text-to-SQL. And I think one thing that is really interesting are semantic layers. So they give you a way to essentially structure all your internal data knowledge and make it explicit. And Malloy is an interesting example of that, because the knowledge is actually embedded or is part of the language. So when you're compiling a syntactically correct Malloy query, you can be sure that it's also semantically correct, which is not the case for regular SQL queries. And the last thing, software engineers, data engineers, they really work a lot in the IDE, and they want to generate, they want to keep on iterating on the same code. So it's not, hey, okay, give me one-off query. I want assistance with writing my query, while writing my query. Small things like, oh, I don't remember the parameters for the regex extract function, or I can't come up with a regex, just recommend one in line. You might have worked with Copilot, GitHub Copilot or Cursor as IDE. So these tools, I think, are really, really useful. But they're missing the context of your database schemas, for example. And they also cannot verify the SQL they generate, or the snippets they generate. So I think there we have a unique opportunity to just make developers' life easier. And one of the things we did is this Fix It. It's a very first start into this direction. Sorry for the small GIF and quick GIF, but when you run a query in the MotherDuck web UI and you encounter an error, then we will make a decision, is this error fixable at all? If so, then we will provide the error message to our fix-it backend, and it will generate a single line fix for the error, and will also validate if that fix makes sense. And then you can, as a user, accept that, and you the latency is very low. It's only 0.6 or 0.7 seconds currently, so you can also stay in the flow of writing your query. Of course, there are also some of these like standard text-to-SQL functionalities in MotherDuck. So you can you can do this text-to-SQL generation for analysts. You can say, okay, I have this schema here, and please generate a query for me. And we take a little bit of this schema, copying the schema over, for example, to ChatGPT and validating the query off of your shoulders. So that's the first chapter. And now I want to go to something that I'm really excited about. We're also going to release a blog post about it later today. So you can still, even if it's too quick or so, you can still go back and to read that. So I want to talk about small language models in the context of databases. And I want to talk about, because actually 50% of columns in databases are text typed. So there are a lot of string values in databases actually. And of course, we have tools like working with regular expressions or getting a substring of a string. But now with this wave of large language models, I think it's really time to also bring those capabilities to the database. And why I think it's a good time now is because the cost per token have fallen a lot in the last year. So when GPT-3 came out, 2020, it cost $20 for a million tokens. Right now, GPT-4 Mini only costs 24 cents for 1 million tokens. If you go to even smaller models, you can get up to like 99.7% lower cost than it would have been a few years ago. And those small models, so models with 8 billion or less parameters, would fall into this small language model category. And they are actually still pretty powerful. So these very small models are doing pretty well on the benchmarks there. So, I'm jumping ahead already. So, this is a new function we have in MotherDuck. With this function, you can actually call small language models to process your data in a database through SQL, and we take care of all the orchestration in the background for that. What can you do with it? What is that useful for? So let's say you're a data analyst working with this data set here. This is one of our example data sets, Hacker News posts. And you see this long text field and wonder, what are these people writing about? Hope it's not too small, but it's very hard to get a quick overview of what the topics of these different posts are about, even when I draw a sample of it. And with this prompt function, I can just prompt a model to give me, for every row, to give me a summary of the, like a five-word summary of the text. And so that's pretty useful. Now I can look at that column and get a really quick overview of what this post is about. So what you can also do is you can use structured output. So you can say, I don't want to have text as response. I actually want to have a typed struct as response from the language model. So we can say, give me the topic, give me the sentiment as an integer, actually. So say 1 if it's really negative, 5 if it's really positive, and give me a list of technologies mentioned in the post. And then you will get a JSON output. So, and what is nice in DuckDB, if you're working with structs, you can actually, you can unnest that struct super easily. And you just have three new columns in your data set. Among others, you have a sentiment classification of the post. So language models are basically like a Swiss Army knife for NLP. They can do a lot of things. And yeah, to the prompt function, they're accessible. But what I think is even more exciting is this world of open models and local inference. So there are all these language models out there, 100,000 new language models every week. We might not need all of them. Every month, we might not need all of them. But some of them could be useful. For example, the sentiment classification. Right? I think it's to use even a small language model for sentiment classification feels quite like a waste. There are a lot of really useful pre-tuned models on Hugging Face that can do that with fewer parameters much more efficiently. And one thing that came out this week is Olama. I showed that earlier for the local model inference. Actually, now supports all models on Hugging Face. So we can do inference on your notebook, and you can even do inference in WASM. Yeah. I didn't explain dual execution. You might want to talk to one of our database people what that exactly is, but it's essentially the way we split work between clients and servers. And I think this inference topic fits in super well. So if you want to not send your data to a third-party API, you can actually leverage your local compute to compute the sentiment, for example, with a specific model with your local GPU potentially, or even MacBooks are pretty good at it by now. Or for embedding computation, which is even more efficient. You can compute 500 embeddings per second in your browser with web GPU using a MacBook. Yeah. So talking about embeddings, we have the same thing for the embedding function. I would take 5 more minutes if that's okay. So you can do things with that. You can start doing things like similarity search in SQL. You can do that as well with the regular DuckDB provides this array cosine similarity function. So that's basically the core of every similarity search, embedding-based similarity search setup. And with this function, you can do the similarity search end-to-end within SQL without having to go to like an external Python script where you compute your embeddings. You can just do it like this, put it in your DBT job, whatever it is, and answer these kind of questions. And you can even build RAG applications fully in SQL with a combination of both. So it's more like funny. I don't know if there's a good use case for that actually, but it's possible. So if you want to try out any of those functions with DuckDB or with MotherDuck, you can just go to the docs, and we also have a free trial where you can get 40,000 prompts per day or 1 million embeddings per day for free, just to play around with it and see whether you like it. And of course, we would be interested in hearing if you like it, what you, or what you not like about it. Really quick about vector search, because we started talking about it. In this example, we're using naive vector search. So what is really great about it in DuckDB, it is super fast. So you can do this naive vector search. So just compute the cosine similarity between your search keyword and your 2 million entries in your table in less than a second. So that's pretty fast, given that a language model also needs a few seconds to respond. So it doesn't actually add that much. So I would say for RAG, actually using the naive search in DuckDB is pretty good. But then there's also the VSS extension for DuckDB that makes embedding search on really large data sets super efficient. And I think that's really useful for things like entity matching, where you have to do like n by m comparisons in your table, and then that thing can really speed up the processing. It comes with the overhead of computing an index. It has a relatively large memory footprint right now. So I think maybe a good compromise is IVF flat, which has a bit lower memory footprint, has also relatively fast index creation, has not the super high QPS, super high recall, but is still reasonable. And now, since a few days or a few weeks, there's a community extension for DuckDB built around FICE. So with this thing, you can also use IVF flat search actually in DuckDB. If you want to do hybrid search, we have a blog post about that. Yeah, I wanted to talk about machine learning. I think, yeah? Okay. Few minutes. So I kind of like that. I really like that machine learning topic because I used to work for a company called HopsWorks before, and they were a machine learning feature store. So that's really my world, just thinking about how do we go from relational data sets in the data warehouse to useful features for a model. And I think right now DuckDB really fits into these two steps, join filter transformations, this feature engineering part of the workload, and maybe we can expand it into either of those directions, go a little bit more towards how can we help with data set search, data discovery, or on the other end of the spectrum, how can we help with machine learning actually? Because I don't know if you know that, but in like a simple thing you can do in DuckDB, you can actually do linear regression just in SQL. And it's an aggregate function. So, and turns out it's also relatively easy to implement k-means clustering in a database engine. It's a mini batch version of k-means clustering. I guess a lot of other data warehouses do similar things when they talk about machine learning in a database. So that's totally possible. And that's just an experimental branch. So maybe there will be a k-means clustering function in the MotherDuck extension one day or in DuckDB. Another thing, also gradient boosting. It was like a bit of a black box for me. Okay, it's this magic thing that does builds a lot of trees and does boosting and this. But actually, you can implement gradient boosted trees fully in SQL. So there's a really interesting paper from this person, and it's even faster than LightGBM or XGBoost. So I think that's a pretty exciting topic. Another direction, or the other end of the spectrum, is this data cleaning and wrangling. This paper kind of triggered the idea with, hey, we should bring prompting to the database layer because it was about data wrangling, and they used language models to do the data wrangling. It worked actually pretty good. There's some follow-up work that we were involved in with fine-tuning smaller models for these different wrangling and data cleaning tasks. And our last paper was about actually code generation. So how can we generate useful SQL snippets that do the data wrangling part without using the model to do the processing of each row, but with using the model more in a text-to-SQL sense? Hey, give me the combination of the right regex expression and this and this and this that leads from my input to my desired output. Yeah, so I don't know if there are any master students in this room. If so, yeah, doesn't look like it. Too bad. But yeah, we have some interesting master thesis topics in that direction right now. If you happen to know someone, feel free to direct them in our direction. All right. Thank you.
At some point during your presentation, you mentioned about in 1 hour you compute 500 embeddings. 1 second. So what are the dimensions of these embeddings? And
I can't remember the name of the model. It was something with all min ML. There's a
the one that OpenAI also uses by default.
Oh no, it's a different. This specific demo was on an open model on Hugging Face. There's this Hugging Face Transformer.js benchmark space, and that was the default model they use. When you look at inference times for the OpenAI embedding models that we're using in production, for batch of 1,000 embeddings, it's around a second, maybe a bit less.
And do you have to use GPU for that, or it also works?
We're using inference APIs, so we are not running that infrastructure currently. But we would really like to go into that direction because that enables open model support for open models.
Okay, thank you.
Yeah.